Hello, this is a quick run through of how to set up your Raspberry Pi at home to run Roon Bridge. First thing I'm going to do is insert a card that's been initialized to the state that our cards were in yesterday. And this will show up as no name. That's how the cards are formatted from the factory. I'm just going to grab this Raspberry Pi images file and drag it to my desktop. I don't need to worry about the other files because I've already installed the applications on my computer. If you haven't, you'd use the links in the email that I sent you to install those. Now that I've got that file folder copied off, I'll start Etcher to reformat the card. Or excuse me, to flash the card. We'll select an image from desktop. We're going to use this Diet Pi image again. SD card readers, this 15.9 gigabyte thing. I'm going to click flash and it'll take a minute. So I'll pause here and come back. Okay, that's just about done. We'll get out of Etcher. And you can see that that SD card now has the name boot instead of no name. The Mac has remounted it with the new name. So next step is to download that Diet Pi Home script. So this is the URL for the Diet Pi Home script. And we'll have to find out where it put it. And looks like I've got a couple of them out here. I'm just going to drag, well, we'll drag this one, it doesn't matter, to our boot drive. And get out of here. And now we need to run that. This window's a little bit large, so on the Mac, it's going to be mounted under /volumes/boot. Mine's got some extra stuff just because I picked up an extra name, but just ignore that. It should be Perl Diet Pi Home. I'm going to give my Diet Pi a name. It's in the kitchen now, so I'm going to call it Kitchen. I do have a Wi-Fi network. I'm going to use the information from yesterday. You'll use information that's specific to your network. And now we have dietpi.txt edited. If I look at it, I can see that it did enable Wi-Fi networking and it set our network setup. That's really all that script does, is make changes to those variables in here. And that's something that Diet Pi uses on the first boot to get itself set up. So with that done, I'm going to properly eject the card to make sure that everything's written. And you can't see what I'm doing right now because I don't have a camera, but I'm going to insert that card into the Raspberry Pi and attach power. And then we're going to wait a minute or so for it to show up on the network. Yesterday we were pinging the Raspberry Pi because we knew in advance what the IP address would be. In my case now, and it'll be in your case as well, probably, you don't know what the IP address will be in advance. So we just kind of have to wait. And we're going to use a mobile application called Fing, F-I-N-G, to scan our wireless network and see when the Raspberry Pi shows up, what its address will be. So I'll show you that in just a minute. Okay, according to my mobile app, the Raspberry Pi has shown up on the network. And this is what I see if I look on my mobile app. We've got this Raspberry Pi. It even put this cute little Raspberry Pi logo here. It's called Kitchen. And it's the only Raspberry Pi that I see on this network. So that's definitely got to be our Raspberry Pi. So let's try to log in. Yesterday we were doing ping test. Today we're using this Fing application to find when it connects to the network. Let me do this real quick. Mac users sometimes will get this error message if you've connected to this device and it had a different host key. We're just going to remove this file to address that issue. We'll accept the host key. You can see the username that we used is root. The password is diet pie. Windows users would use that PuTTY application to do the same thing. We'll accept the license, and the Raspberry Pi will proceed to update itself. So we'll pause here for a minute. Okay, looks like that process is completed. So I'm going to say OK to let this finish its update process by rebooting. And that logged me out. If for some reason it doesn't log you out on a Mac, you can hit Enter and then tilde dot, and that will disconnect you. Here it's not going to do anything, but if you get hung, that's a useful trick. PuTTY users will get kicked off, and you can use that menu option up in the top left-hand corner to duplicate your session or reconnect. So we could ping this if we wanted to. Let's see when it's back up. It looks like it is. I'm going to try to SSH in, and I'm probably going to get that error message again. So let's just remove that file one more time. Windows users don't have to worry about that so much. Diet Pi is the password. And we're back in. We'll accept the license agreement again. And this is going to give us some options to set up our Pi. I'm going to do a couple of things a little bit differently than I did during the demo because I've got a little bit more time. The first thing that I usually do actually is go to Diet Pi config and advanced options. And there's this update firmware thing. And what that does is, it sounds like firmware, but it's actually updating the Linux kernel that is on the Pi. And I talked about the kernel briefly yesterday. What the kernel does is it contains all the drivers to talk to the hardware. And so if there are kernel updates, they would contain drivers, maybe updated drivers for your DAC. So it's a good idea to do that periodically, or if you're having trouble with the Raspberry Pi recognizing your DAC. So I'm going to say OK here. It's going to take a minute to download a few files. Okay, great. It looks like that process is finished. I'm just going to hit escape to go back to the previous menu, and escape once more. And I'm going to exit Diet Pi config, and that'll take us back to where we started. Now we want to actually install Roon software so that we can use this as a Roon output. So we'll go to this Diet Pi software selection tool here, and I see Roon Bridge. I'm going to move my cursor down to that line 121 and hit the space bar to select it. Tab down to OK and go out. Sometimes I like to install some additional software. This is totally optional, but sometimes it's nice to have the Linux sound system tools on just for kind of playing around in FFmpeg for converting formats. It's not really necessary for our application, but those are things that you could do optionally if you wanted to. I'm going to escape out of that just to save some time. Those are things you can play with on your own time. And the most important step here, we're going to go down to install. If we don't do this install step, it actually won't install any software, so pretty important. And this is going to take a minute to run, so we'll pause here. Okay, so that software update process finished, and the Pi is rebooting. We will run our ping command again, just to kind of watch and see when it comes back online. We can do that since Fing told us what the IP address is. And depending on your home router configuration, the address will typically stay pretty static once it's initially set. A lot of routers have some kind of way to set a specific IP address if you want to do that with yours so it's more predictable. I'm just going to leave mine the way it is. All right, so we're logged in. I'm going to go ahead and connect to DAC now so that we can see if anything shows up. But before I do that, if I run aplay-l, that'll list the different audio hardware devices that we have, and we can see we've got a couple. One up here, that's the built-in headphone jack that's on the Raspberry Pi. Doesn't sound so great. I guess it might be okay for background music. There's also HDMI audio, which I don't really recommend either, just because it requires a video signal, but in a pinch you can use that if you need to get sound out to a television, for example. Let me connect this DAC and let's see what happens. All right, I've connected the DAC via USB. There's a command called dmessage. It's a Linux specific command that I can run to see if the new DAC was detected, I see this product iFi thing on here. That's the iFi is the manufacturer of the DAC that I attached. If I run aplay-l now, I can see I have 3 devices. I still have the 2 ones that are built into the Raspberry Pi itself, and now I have a third one, this iFi by AMR. That's this iFi Nano IDSD DAC that I've attached. We're going to go through another quick round of settings that I didn't show you when you were here yesterday. We'll run diet pi config and go back to audio options. We can see that the sound card is still set to this Raspberry Pi built-in thing, and I'm not going to use that, so I'm just going to go ahead and set that to none and disable it. In some cases, if you're using one of these add-on cards, it's necessary to pick them from the list. You can see there's some hi-fi berry options here, and the only case where I've actually had to use any of these was with the hi-fi berry amp. The amp wouldn't show up unless I had it selected. All these other devices, I've tried the hi-fi berry Digi Plus Pro and the DAC Plus Pro. I didn't actually have to select anything here, and it actually ran a little bit better without these things selected. So experiment with none and see if that works for you. If it doesn't, try a specific setting for your DAC. There's also a generic USB setting down here. I found that I didn't need to use that I haven't had to use that for any of my USB DACs so far. So none, just to keep things simple. Another optional thing you can do is turn power supply noise reduction on. As audiophiles, noise reduction sounds like a good idea. Be aware, though, that it will disable your HDMI output. So if you were using HDMI output, connecting the Raspberry Pi to your television or something, that will stop working after this. And the only way that you'll be able to get into it is over the network using PuTTY or SSH from a terminal window. I'm going to hit escape to go back out. Escape once more. Exit diet pi config. I'm going to be advised that this will cause it to reboot, and this should be the last reboot we have to do. So we'll ping it, wait for it to come back online. Usually it takes about 10 seconds. Maybe a little bit longer since we've got, there we go, 10 seconds. We'll log back in one more time. Again, password's diet pi by default. You'll also notice when you log in, you get kind of this nice screen here that gives you some commands that you can run. There's this diet pi launcher thing that helps you with all the different menu commands you might want to run. When you log into this screen a few months from now, you might see that it wants you to do an update, and it'll tell you to run this diet pi update command to bring your diet pi installation up to date. It's optional, but sometimes it's a nice idea to try to stay current in case there are bug fixes. But I'm also a subscriber of the philosophy that if it's not broke, don't fix it. So if everything's working for you, you don't really need to do any of that. It's only if you're a tinkerer like me or you're just interested that you could explore those things. We're going to run aplay-l again, and now we only have one audio device. I think that's just, since we've set that card to none, it's just a sort of a cleaner way to set this thing up. And when I go into Roon, it'll be simpler to find my device. I can also type CPU to see how cool my CPU is running. It's pretty cool right now, and because I've enabled that power save thing, the software has downclocked the 4 cores that are on the CPU from 1200 megahertz to 600 megahertz. That's going to produce less noise on the power supply and less, probably less radio frequency noise and that kind of thing. It's just handy, and we don't need much CPU in order to drive the DAC. So with that all done, we've got our Raspberry Pi set up. We need to go to Roon and adjust some settings there, so we'll do that next. All right, for this next part, we're going to configure Roon to actually talk to our new zone. And there are a couple different ways that we can do it. A lot of times when you start Roon for the first time, it's going to ask you a couple of questions. Do you want to run this Roon as a server to manage your music library? Do you want to run it just as a remote control? We're going to use it as a remote control. That's what I'm doing here. And you should have a server, Roon server running someplace else on your network. It could even be running on the same computer. The next thing it'll ask us is to select an audio zone. So we don't have one selected right now. I'll click on Select Audio Zone, and you may not see anything here. These are some Sonos things that I have around the house and some other Raspberry Pi devices. The main thing we want to do here is go to audio setup. So we'll pick audio setup. We want to try to find our Roon device here. Remember I called it kitchen, so I'll scroll down until I see kitchen. I've got some other Raspberry Pis hanging around on the network, but kitchen's the one we're working with today. It looks like the Linux kernel is a little bit more up to date on my kitchen one, so I could do firmware updates on the other ones and bring them up to this level if I wanted to. You can see that it recognized the iFi by AMR HD USD audio DAC, but it's not enabled, so we can't play anything to it until we enable this zone. So I'm going to click enable, and mostly the only thing I change here is the volume control mode. This particular DAC has a hardware volume control on it, so I don't need to use any kind of software to control it. I'm just going to click fixed volume, and sometimes it's helpful to set the maximum volume at playback. It's not always necessary, but we'll go ahead and pick that here as well. We don't want Roon trying to sort of decimate the digital audio that's going to the DAC to control volume. Even though Roon's internal volume control is very high quality, we just don't need it for this particular hardware. And if you're going to be using your DAC with sort of line outs into integrated amplifier or preamplifier, I recommend using the fixed settings as well. On the playback tab, we can see that it recognized the capabilities of the Roon DAC. It's capable of all these different BCM rates. It can't do anything above 384 kilohertz. And it recognized that it does DSD up to 256. If for some weird reason I had some audio that was in one of these red formats, Roon would detect that automatically, and it would do high quality sample rate conversion to match the capabilities of the DAC without me making any changes. So that auto detection feature is pretty nice, and it works pretty well. There's some DSD conversion options here, but I'm not going to worry about those. I'm just going to save the settings as they are. So now I have this Roon output. I'm going to call it, you can see I've called it here DSD, iDSD Nano. I'm going to change it to kitchen, since that's where this thing is. It'll make it easier for me to find it since I know where that zone is in my house. If I go back here now, I just clicked out of that window, just anywhere. That's how you get out of menus in Roon. It's a little, takes a little getting used to. There's these different radio buttons if you have more than one zone. I'm going to pick kitchen, and that selects this zone. You can group zones together and transfer audio from one zone to another, so those are options that you can experiment with. But right now I'm just going to have that zone by itself. And now I can go cue up my new favorite Laverne Butler album and hit play. And I see that I've got some progress here. If I plugged headphones in, I'd be able to hear the music. This little dot here on Roon will show us what the output chain is. And right now the signal path is lossless. It's a nice thing to know that that's actually happening. We see that the source is Redbook CD resolution FLAC. It's going to over the Roon's advanced audio transport to the kitchen and playing through the DAC. Now I can do some fancy things here. I want to pause this for a second. Go back to my zone and open up this DSP engine thing. And I can, if I want to play around with it, I can try sample rate conversion. Let's try max PCM rate power of 2. I want to set that to enabled. And there's some options here that you can specify. You can do some reading on the internet to figure out whether minimum phase or linear phase is what you want to try to do. I'm going to leave the defaults right now. I could choose a 5th order, 7th order, and all these other different options. Some of these are new since the last time I was in here, so that's pretty cool. It's one of the things that's nice about Roon is that they're always updating these things. I do need to make sure that the DSP engine's enabled and that the settings under this tab are enabled. I've got apply changes happening automatically, but these both have to be enabled in order for any of this stuff to happen. There's some other interesting filters that you can mess around with later on as well. And there's even more under here, including convolution, multiple EQ type settings. But right now we're just going to do the sample rate conversion thing. And the only reason we bother with this at all is that some DACs just seem to like certain sampling rates better than others. And so it's just a way to kind of experiment with the sound and see if you find something that you like a little bit better. It's not going to add any information to the tracks that wasn't already there, but it might get the stream into a format that the DAC prefers and performs better at, and that's sometimes worth doing. Unlike a traditional media player, This process happens on Roon server, which ideally is located someplace else in your house, far away from your listening room. So all the additional CPU usage and number crunching that it's doing is not going to affect the sound in your listening environment, since the Raspberry Pi is not doing any of that processing. It's just simply listening on the network for an audio stream from your server and sending it to the DAC. So I've done all that stuff. I'm going to hit play again to start playback back up, and we'll take a look at this signal path again. Now, instead of saying signal path bit perfect or lossless or whatever it said, it says enhanced. There's a few more things in here. So it's doing a bit depth conversion from 16 bits to 64 bits. Roon's internal audio processing path is always 64 bits. It's a higher resolution floating point calculation. It's doing sample rate conversion from 44.1 to 352.8 kilohertz. We're presuming that the highest sampling rate that our DAC's capable of is also the one that it sounds best at, which is probably not actually true, but that's what's going on there. You'll see that I had a network problem. I'm doing this over Wi-Fi, so I'm sending an awful lot of data over the Wi-Fi network. This is one of the reasons that I do very strongly recommend a wired connection for these Raspberry Pis if you're going to be playing high-resolution audio, or just in general. It just seems a little bit more stable. We're really kind of pushing the limits of the Raspberry Pi connection here. Now, Roon knows that DAC likes 32-bit as actually its input format, so it's converting from 64 bits back down to 32, streaming it over the network, in my case this Wi-Fi network, using the advanced audio transport and out to the DAC. And if I did more DSP options, all those things would show back on that playback chain. And you can have, all these DSP settings are specific to each zone, and in fact, you can have them be different across your different zones. So you could be doing room correction in some zones and traditional parametric equalization in other zones. And all those settings are saved by Roon and managed by Roon, and can all be controlled from one place. Some of the Roon mobile apps, including I think the mobile apps for Android, don't have a menu option for accessing the DSP settings, but they are available on iOS tablets and on the Roon desktop app. So just keep that in mind. If you're using a mobile app, you may not be able to go in and change these things, but typically you set them once and forget about them. So I hope this has been helpful. Again, as always, if you have any questions, don't hesitate to reach out to me. Cheers.